Let us try to understand continuity of a composite function f of gx. So f of gx will be discontinuous wherever gx is discontinuous or gx is undefined. So we will check at points where gx is undefined or discontinuous. And at what other points? At points where gx takes the values at which fx can be discontinuous, where gx takes values at which fx is undefined or discontinuous. Okay, let's try to understand the concept using a problem. Here fx is 1 by x and the input function gx is x square minus 1. So first of all, check is this any a discontinuous function? So no. X square minus 1 is a polynomial function or a quadratic function. It is continuous in R. So at what other points we need to check? We need to check wherever gx takes the values when fx becomes undefined. Fx is 1 by x. So 1 by x is discontinuous or undefined at x is equal to 0. We will check if gx is capable of taking value 0. If yes, then at what values of x? So gx will be 0. This gives us x square minus 1 is equal to 0. X is equal to 1 or minus 1. We get two values of x where gx becomes 0. Now, if we define f of gx, it will become 1 upon x square minus 1, which is obviously discontinuous at 1 and minus 1 both points because f of gx will be undefined at both these points. So if fx is undefined at these points, functional value will not be obtainable at 1 and minus 1. Hence the function will be discontinuous at x belonging to minus 1 and 1. Let's try to understand this better by a next. So here fx is 1 upon x plus 1 x minus 2 and same gx is the input function. Gx is 1 by x squared. So first of all, check if this function can be undefined or discontinuous at any point. So yes, this is undefined at x is equal to 0. So we will check continuity at x is equal to 0 and at what other values? At points where gx takes values where fx is undefined or fx is discontinuous. Fx is undefined at x is equal to minus 1 and at x is equal to 2, where denominator of f becomes 0. So we will check if gx is capable of taking this value minus 1 and value 2. So check if gx can be equal to minus 1 or gx can be equal to 2. If we check gx is equal to minus 1, 1 by x square is equal to minus 1. So some positive value cannot be equal to minus 1. So no solution. From here gx is equal to 2. 1 upon x square is equal to 2. So x becomes plus minus 1 by root. So the function will be discontinuous at x is equal to 0 for obvious reasons that if we define f of gx and find f of g of 0 at 0, gx is not defined. So f of g of 0 will also not be defined. So it will be discontinuous at x is equal to 0 for sure, and we need to check for x is equal to plus minus 1 by root 2. Let us write f of gx. the g function is 1 by x square and the f function is 1 upon x minus 1. Here it was plus 1 and x minus 2. So if we write f of gx, it will be equal to f of 1 by x square, which becomes 1 upon 1 by x square plus 1 into 1 by x square minus 2. And now if we calculate limit x is tending towards 1 by root 2 f of gx, it goes towards infinity, because if we go towards 1 by root 2, here we put 1 by root 2, this expression will go towards 2, 2 minus 2 will go towards 0, either 0 plus or 0 minus. This expression will reach towards plus minus infinity. Hence the limit will not be defined at either we go at 1 by root 2 or we approach minus 1 by root 2. This limit will not exist. Hence if limit does not exist, the function will be discontinuous. Hence f of gx will be discontinuous at three values, that is minus 1 by root 2, 0 and plus 1 by root 2. This will be the answer. Okay, thank you.